Okay, so today we're going to look at historical counting, and we're going to start converting binary numbers to base 10. Binary number is base 2. So here is how this works. If you think about a regular good old number, something like 123. Right? Well, this is times 100, this is times 10, and this is times 1. So this is 1 times 10 to the second power. This is 2 times 10 to the first power, and this is 3 times 10 to the 0 power. Anything to the 0 power is 1. So that's what we do with our base 2 numbers. So our first base 2 number is 1, 0, 1. So this is times 2 to the 0. This is times 2 to the first. This is times 2 to the second. So this is 1 times 1. This is 0 times 2. And this is 1 times 4, which is 4. This is 0, and this is 1. Add them up. And in base 10, that would simply be 5. So let's look at another example here. We have 1, 0, 1, 1, 0, 1. And this is base 2. So again, 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. So I have here 1 times 1. Here I have 0 times 2. Here I have 1 times 4. Here I have 1 times 8. Here I have 0 times 16. And here I have 1 times 32. So this is 32. That's 0. That's 8. That's 4. That's 0. That's 1. And I get 45. Okay, so I've done a couple examples, so I'm going to skip this one. Example 3, I'm going to skip it. If we need to work it, we can do it in the live classes. And now we're going to go the other way. We want to convert 45 to base 2. So let's do this way. We start with 2 to 0, which is 1. And we have 2 to the 1, which is 2. We have 2 to the second, which is 4. We have 2 to the third, which is 8. We have 2 to the fourth, which is 16. We have 2 to the fifth, which is 32. 2 to the sixth would be 64, so we do not need to go that high. So now let's look at our base 10 number, 45. And we look at how many 32s will go into that. Well, 1 will. And that will give us 32, which will give us a remainder of 13. So how many 16s will go into that? Well, 0. How many 8s will go into 13? 1, which is 8, leaving a remainder of 5. How many 4s will go into it? 1 again, which is 4, leaving a remainder of 1. 2 does not go into 1. 1 goes into 1 one time, and we're done. And then this, from left to right, up to down. We have 1. Don't forget the zeros. 1, 1, 0, 1. And don't forget the base. And that is it. Okay, let's do another base 2. So again, we have 2 to the 0 equals 1. 2 to the first equals 2. 2 to the second equals 4. 2 to the third equals 8. 2 to the fourth equals 16. 2 to the fifth equals 32. 2 to the sixth equals 64. 2 to the seventh is 128, so we don't need that. So we have our 126. 64 will go into that once, leaving 62. 32 will go into that once, leaving 30. 16 will go into that once, leaving 14. 8 will go into that once, leaving 6. 4 will go into that once, leaving 2, and 2 will go into that once, leaving 0, and don't forget that 0. So what do we have? We have 1, 1, 1, 1, 1, 1, 0, base 2. Don't forget the base. A thing to remember is if your base is 2, the numbers in the digits, or the numbers for the digits, will not be 2 or greater. They'll be less than 2. If you have a 2 in here, it's not right. Okay, so let's look at converting to base 8. It's the same principle. 8 to the 0 is 1. 8 to the first is 8. 8 to the second is 64. And I don't think we need to go any further. So we have 486. 64 goes into 486. 7 times, which gives me 7 times 64. And don't be afraid to use your calculator on this. Gives me a remainder of 46. 8 goes into 46. 5 times is 40. Remainder of 6. 1 goes into 6. 6 times 0. So we have 7, 5, 6, base 8. Okay, convert 73 to base 3. So what do we have? 3 to the 0 is 1. 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. 3 to the fourth is 81. 3 to the fifth is 243. And we won't need to go any higher on that. So we have 237. 243 goes into 237 one time, giving me 243 with a remainder of 30. 81 does not go into 30. 27 goes into 30 once, which is 27. Remainder of 3. 9 goes into 3, 0. 3 goes into 3, 1. Leaving 0, and we have 0. I have 1, 0, 1, 0, 1, 0, and don't forget the base. It looks like a base 2 number, but it's actually base 3. Make sure you're careful with that. Okay, now we're going to look at converting a base 6 number to base 10. I have 4, 5, 3. And that's times 6 to the 0, times 6 to the first, times 6 to the second. So this is 3 times 1, 5 times 6, and 4 times 36. And again, don't be afraid to use your calculators. You are allowed. 4 times 36 is 144. 5 times 6 is 30. 3 times 1 is 3. 173. Now, if it's a base 10 number, of course, you don't have to put the base. Any other base you do, otherwise it's assumed it's base 10. Okay, so now we have a base 8 number that we want to convert to base 10. Write it out here. 5 times 8 to the 0, 1 times 8 to the first, 6 times 8 to the second, and 3 times 8 to the third. This is 5 times 1. This is 1 times 8. This is 6 times 64. And this is 3 times 512, which is 1536. 6 times 64 is 384. 1 times 8 is 8. 5 times 1 is 5. Add these up. 1536 plus 384 plus 8 plus 5, and we get 1933. Okay, the next thing we have is base 16. Now this is how this works. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's our number system base 10. And we had A, B, C, E, and F. So A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So let's look at what we have here. We have 7, D, E. So first, let's translate this. That's still 7. D is 13, and E is 14. Now this is times 16 to the 0, times 16 to the first, times 16 to the second. So I have 14 times 1. I have 13 times 16, and I have 7 times 56. And this is 1792. And this is 208. And this is 14. 92 plus 208 plus 14. And we get 2014. Okay, example 11 would be done the same way, except you're going to need 16 to the third. Let's set it up for you, and then C, 6, 7, 9. So this would be 9, 7, 6, and C is 12. And that's times 16 to the 0, times 16 to the first, times 16 to the second, times 16 to the not 13th, third. And I'll let you guys take that from there. Okay, now we're going to go the other way. So I have 493, and I want to convert it to base 16, which is called hexadecimal. So I have 16 to the 0, which is 1. I have 16 to the first, which is 16. I have 16 to the second, which is, was that 512? Oh, 256. Okay, and we don't need 16 to the third. Okay, 256 will go into this one time. 256. 237. 16 will go into 237 14 times. 224. And 1 will go up, remainder of 13, and 1 will go into 13 13 times. So 13 was what? D? This is D, that makes 14E, and this is just simply 1. So our number is 1ED base 16. Again, problem 13 is done the same way, so I'm going to leave that to you. And we'll move to counting boards. Okay, so counting boards are interesting. Here's how this works. These numbers around here, or these blocks here, represent 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. These two represent 2. The center area represents 3. The slightly raised areas represents 6, and this area here represents 12. This is a 3-level board in reality. The white is the lowest level, the gray is the middle level, and the darker gray is the top level. So let's look at this problem here and see what we got going on. Suppose you have the following counting board with two different kinds of pebbles placed as illustrated. Let the solid black pebble represent a dog and the striped pebble represent a cat. How many dogs are being represented? How many cats are being represented? So how many dogs? Let's look at dogs. Dogs were black. So there's 2, and that's it for 1. So 2 times 1. We have these 3 here. So 3 times 2. We have this one here. So 1 times 3. We have these here. So 3 times 12. And we have this one here. Or 3 times 6, sorry. 1 times 12. That's 18. That's 12. That's 3. That's 6. That's 2. 11, 29, 41 dogs. And now let's look at cats. Okay, start with our ones. We got 1, 1, which is 1. We have any 2 cats? No. How about 3? They got a whole bunch here. 2, 4, 6 times 3, which is 18. Okay, then I have these 3 here in the 6th level. I have 3 times 6, which is 18 again. Then I have these 2 here, which is 2 times 12, or 24. That's 36, 61 cats. And that's it. That's how that works. I don't believe there's a counting board on the test, but there are some in the homework. Okay, I'm going to skip this one as well. I don't think you have an issue with that. Same problem. We just have 3 different things. And you probably need to blow it up to look at it. Yeah, there we go. Okay, next up is something called the Mayan numeral system. So 2 things to note. They didn't have numbers like we have. They had symbols. And here is the list of symbols. And then what they mean. Now, the interesting thing about the Mayan counting system is they use base 20. So let's look at this stuff and see what we got going on. Convert this to base 10. So first, let's just look at what this represents. We have 2 lines and 3 dots. So this is 13, and this is 3. Now, this is times 20 to the 0, and this is times 20 to the first. I have 13 times 1, and I have 3 times 20, which is 60. This is 13, 73. That's it. Not difficult. Here I have 3, 0, 3. This is times 20 to the 0, times 20 to the first, times 20 to the second. So this is 3 times 1. This is 0 times 20. And this is 3 times 400. So this is 1200. That's 0. That's 3. And we get 1203. Again, these are base 10 numbers now, so we don't have to include the base. Okay, one more to go. So this is 0, this is 0, this is 10, and this is 12. That's times 20 to the 0, times 20 to the first, times 20 to the second, times 20 to the third. So this is 0 times 1, which is 0. This is 0 times 20, which is 0. This is 10 times 400, which is 4,000. And this is 12 times 8,000, which is 96,000. And we get 100,000. And that is it. So that's it for this chapter. Have a good day, and I will talk to you next time.